Welcome to this presentation in the series, Electronics, the Story of One Human Lifetime, presented by David Beams and Gary James. I am David Beams, Associate Professor Emeritus of Electrical Engineering with the University of Texas at Tyler. Today's presentation is going to be a little different than others that have been produced in this series. We're going to look at past technology. We're going to look at the origins of my engineering career, but there are no equations, no derivations, no Laplace transforms, Kirchhoff's voltage law, none of it, just stories. I think it'll be fun. But before we get going, just as a note to our loyal viewers, maybe all three of you, you may be wondering, where is the good and cultured Mr. James? Why don't we see more of him? I will admit he is more telegenic and he is a far better presenter than I am, but the COVID-19 pandemic has made face-to-face cooperation very difficult, but I assure you, as soon as possible, we will be seeing more of the debonair Mr. James. But for the moment, let's go back to some memories of a company called Sangamo Electric. This is the Sangamo Electric logo. Sangamo is kind of an odd name. It is a variant of Sangamon. Sangamon was the name of a river in central Illinois. Sangamon itself was derived from a French transliteration of a Native American place word. Sangamo was founded in 1899 in Springfield, Illinois. Engineer Robert Lanphier collaborated with inventor Ludwig Gutmann to turn Gutmann's ideas for an electric power meter into practical form. Sangamo operated in Springfield from 1899 to 1978. And its principal product during that time was the watt-hour meter. However, it also made capacitors, electromechanical time switches, tachographs. Tachographs were devices that would produce chart-type records of speed of a truck or a bus versus clock time. They produced sonar systems for the Navy from 1940s through early 1970s, FM tape recorders, and data entry workstations, which would simplify the process of entering data into for computer processing. It would go directly from keyboard to mag tape, bypassing the key punch stage. Unfortunately, the Sangamo data station was not a commercial success. So how does a mechanical watt-hour meter operate? I found a patent that it was assigned to Sangamo Electric, I think would give us some qualitative feel for how the watt-hour meter works. Here is the basic mechanism of an electromechanical watt-hour meter. We have the AC line. We have connections to the load that's being supplied by the line. We have an aluminum disc, which we're seeing edge on. We have a voltage coil, which is across the AC line and consists of many turns of very fine wire. And we have a current coil that's in series with the load that has a few turns of very heavy gauge wire. And the last element is this braking magnet, which is just a permanent magnet whose purpose is to provide a torque on the disc, a braking torque, which is proportional to the angular velocity of the disc. Figures 2 and 3 of the patent give us some idea of the operating principle. Figure 2 shows the eddy currents due to flux, time-varying flux from the voltage coil. Figure 3 shows eddy currents due to flux from the current coils. Now, neither of these two patterns of eddy current could produce a magnetic moment that would provide torque to turn the disc. However, if you combine the two, have fluxes from both the voltage and the current coils, you see that the eddy currents from the voltage coil will augment these eddy currents while diminishing these eddy currents. And this asymmetry in the magnetic moments gives rise to the torque that turns the disc. Here we have, from that same patent, figure 4 shows two of these voltage and current coil assemblies at opposite sides of the disc to make a two-phase watt-hour meter. And figure 5 showed this element as a high permeability flux shield to provide magnetic isolation between the two coil units. And a front view of the meter in figure 6 where you can see the disc and you can see the two voltage and current coil assemblies. Sangamo Electric had a summer student program. The summer student program was a mutually beneficial arrangement. They hired engineering and science students to work for the summer, gave you some practical experience and some money. And at the same time, it kind of worked as a farm system for Sangamo. They brought to bring in prospective new hires and get a chance to look at them before making a commitment as to whether this is someone they'd like to hire or not. This is the class of 1972, and that is me, almost 50 years ago. And this is my badge. To get into the plant, you had to have an employee ID badge, and there were security guards at each door, and they would check to make sure you were displaying your badge as you walked in. And I remember the entrance where I usually walked in, there was a guard who would stand there swinging his hands back and forth. And as a male employee approached, he would say, "Good morning, sir. How you doing, sir?" You know, pleasantries like that. But when a female employee appeared, he would leave his post. He would walk out into the parking lot and he would gallantly escort her to the door, usually with his arm draped over her shoulder. That kind of behavior would probably not be tolerated today, but this was 1972 and the rules were different. A couple of other people I want to point out in this photograph. This gentleman here, his name was Muhammad Ali. I tell people I worked with Muhammad Ali. Obviously, he's not the boxer, but I don't have to say that when I drop his name to others, right? This person, Nancy, was the first person I ever knew who owned a Japanese car. It was such an exotic thing to see a Japanese car in that day. We did not know that within a decade they'd become ubiquitous on American roads. In the summer of 1972, I worked in the Thermometer Laboratory. So what is a thermal demand meter? Anyway, I couldn't find a copyright-free photograph of a Sangamo thermal demand meter, so I made a sketch. Sangamo sold their meters under the name Lincoln meter. Quite frequently, but not always, a thermal demand meter had a peak reading pointer that could be dragged along upscale by the indicating pointer here, which is the black pointer in this illustration. But then when the indicating pointer went back downscale, it would leave the peak reading pointer at its maximum value. Well, I could not find any patents that were assigned to Sangamo Electric related to thermal demand meters, so I will have to use illustrations from patents assigned to other companies to explain their principles. Here is a combination watt-hour meter and thermal demand meter from Duncan Meter of Lafayette, Indiana, patented in 1950. Here you see the watt-hour meter dials. This is the thermal demand meter unit. There are the pointers and the scale of the thermal demand meter. Now, let's take a look at the principle of operation of a thermal demand meter. And the heart of it is two bimetallic coils wound on a common shaft. And you notice that they're wound here in opposite directions. As temperature changes, the bimetallic coil's length changes. It either tightens or loosens depending upon the temperature change. But by having two identical coils coupled to a common shaft, they generate equal and opposite torques which cancel. So the pointer that's attached to the shaft is not affected by ambient temperature. But if I can differentially heat those two coils in response to some electrical quantity, I can make a meter that is responsive to that electrical quantity, be it amperes, or be it current in amperes, be it watts, be it bars. This basic principle of the thermal demand meter. Here's a patent from Westinghouse from 1943 where we see the bimetallic coils and the heating elements. And from that Westinghouse patent, they show a method of providing differential heating to the two elements based on power. In this case, they have the heating elements and they have a voltage pickup coil. It was a second coil wrapped around the voltage coil of a watt-hour meter element that was the means of providing the imbalance between the two heating elements. I'll leave it at that. I don't said no equations, not going to go there. What did I do with thermometers in 1972? A lot of what I did was clerical. I spent a great deal of time going through past records. I was compiling a master list of current and voltage transformers used in thermal demand meters going back to the 1930s. It's rather boring, but I did have a little to do with the peak reading pointer assemblies that summer. Now, this sketch is one that I drew. I can't find a picture from a patent or any other source of what this assembly consisted of, so you'll have to, this may not be the most faithful representation of it, but it'll work for explanation purposes. It has a pointer, this little hook or flag that was meant to catch the indicating pointer that would pull it upscale. There was this housing with a cover and a disc. The disc fit inside the housing. There was a very small gap between the housing and the disc, and that was filled with a thin layer of silicone grease. The idea being that the silicone grease did not provide that much resistance for the pointer to be pulled upscale by the indicating pointer, but it provided enough resistance to hold the pointer in place when the indicating pointer backed away. This complete assembly was called the clutch. The viscosity of that silicone grease was vital. Controlling that viscosity was vital to the proper operation of this peak reading pointer assembly. And they actually had a test for viscosity, and I remember doing that. The viscosity test involved an aluminum sheet. We put daubs of the silicone grease on the sheet, turn the sheet vertical, and measure how the grease streaks ran down the face of the sheet. And the rate at which the grease ran down the sheet was correlated to the viscosity. I don't remember the details now, but the results of this test told us whether the grease was suitable for use in these clutch assemblies. Yeah, there's the grease streaks. The Thermometer Laboratory was located on the ground floor of the Sangamo Electric building. The windows faced east. This is north going off to the right, and about 2 blocks north of there was a pool, a municipal swimming pool called Memorial Pool. And we would not infrequently see young people in swimsuits walking by on the sidewalk. That actually is an element of a story I'm about to tell. There were 3 engineers who worked there, Don, Bob, and Jim. Trevor was the supervisor, and they gave me a desk right out here. Now, one day, Don was standing over by the windows, and he suddenly blurts out, "Hey guys, got a load of this babe in this bikini," and we all go scrambling over the windows to see this sight. And bikini, yes, that was right, and babe, that certainly was right. She was maybe all of 6 or 7 years old, and we wanted to strangle Don, but he had us, I have to admit. Now, Trevor was old school. I shouldn't have clicked on that yet. Okay, bear with me. Trevor was kind of old school. He, here we go, came from England, I believe, or possibly Australia. He definitely had an accent, and he had old school ideas. I remember one time that I told him that I would study late. I would frequently get out of bed in the morning just enough time to throw on my clothes and go to class. And he looked at me with absolute horror and disgust. And he said, "Why, when I was at university, I wouldn't have dreamt of going to class if my suit weren't pressed." And I thought, suit? What planet are we on here? But I did manage to redeem myself in Trevor's sight, I think. I was doing a measurement. I don't remember what I was measuring, but I was doing a measurement using a precision analog meter like this one. Now, these were the days before digital panel meters. The really accurate meters of the day incorporated a mirror inside the meter scale. Trevor's looking over my shoulder and he says, "So why did they put that mirror in the meter scale?" And I said, "Well, when you read the meter, you align the needle with its image in the mirror, and that eliminates parallax errors." And he looked at me with absolute astonishment and said, "Well, so they did teach you something at school after all." But the funniest story of that summer came about from the visit of a sales engineer named Wayne to the Thermometer Laboratory, and he came to tell Bob a riddle. And it was the riddle of the 3 traveling salesmen, which I think is worth repeating. There are 3 salesmen traveling together by car. It's getting late, and they agree to stop for the night at the motel in the next town. Well, the next town has only one motel, and the clerk tells them there's only one room available, so they're going to have to share it if they want to stay, and it rents for $30 a night. They're not happy with the arrangement, but they're too tired to continue, so they agree to take the room. Each man gives the clerk a $10 bill, and the men carry their things down to the room. A short time later, the clerk realizes he's made a mistake. It's a $25 room that he'd rented to them. He takes 5 ones out of the cash register and heads down to the room to refund the overcharge. But on the way there, he thinks, wait a minute, you can't divide 5 $1 bills among 3 men. So to solve the problem, how is he going to do that? He pockets $2. He knocks on the door. The salesman opens it. The clerk explains he had overcharged them and gives each man back $1. So let's see where we are. Each man paid out 10, got back 1 for a net payout of $9 from each of the 3 of them. 3 times 9 is 27. Add to that the 2 the clerk pocketed, and you get 29. But they originally paid $30. Where's the missing dollar? Now, I overheard the whole riddle, but from where I was sitting, I was out of sight of Bob's desk. He did not know that I had overheard it. It took me about 15 minutes to see through the riddle and solve it. And so I went back to work. And this started at about 11 o'clock in the morning. And for the remainder of that hour, though, I could hear Bob down in his cubicle muttering about it, trying to solve the riddle and not getting anywhere with it. Then he went off to lunch. Well, stop now if you don't want to hear the answer. I told you that I figured it out. I'm going to go ahead and explain it. But if you want to try to work it out for yourselves first, I'll give you a few seconds to pause the video. That should do it. Okay, if you're here, I assume you want to hear the explanation. The $27 paid by the salesman was $25 for the room plus the 2 taken by the clerk. Add to that the $3 refunded and you get $30. There's no missing dollar. The riddle is verbal sleight of hand. The deception is to establish in your listener's mind that the $2 is in addition to the $27, not part of it. Well, right after lunch, Bob made a straight line from my desk, and he started to tell me the riddle. I gave him no indication whatsoever that I had already heard it or solved it. I just let him set the whole thing up. And when he finished the riddle, this is what I told him. I said, Bob, that's a riddle? Why, a 5th grader could see through that one. And I told him the answer, and he went away just absolutely livid. I never did tell him that I let him set himself up. My relationship with Bob wasn't the greatest. I admit it was at least partially my fault. I remember we got off on the wrong foot early on in my employment there. I was heading for the Thermometer Laboratory at 5 o'clock to pick up my things to go home. And I happened to cross paths with Bob in the hallway. He was heading for the exit as I was heading back to the laboratory. And without even looking at my watch, I said, oh, it must be 4:45 already. That was probably not a good thing to have said. Anyway, so that was 1972. Here's 1973. Sangamo employees of that year, and there I am. I worked in several electronics laboratories that summer, bounced around from one to another, and in one of them I had my very first experience with an HP35, the world's first scientific calculator, which sold for $495 in 1972. Here is a photograph of an HP35. It's still functional. You can see the display is showing the value of the square root of 2/2. This photograph, by the way, was taken by Gary James in 2019. This calculator is still functional after all those years. But I went to one of the engineers, and I was doing some sort of calculations involving logarithms, and I went to ask if he had the CRC handbook of math tables. And he said, yes. And he reaches up and starts pulling off the shelf. He said, what do you need it for? And I told him what I was doing, and I needed to do some logarithms and exponentials. And he said, well, why don't you puts the book back and pulls the drawer open and pulls out his HP35. He says, why don't you borrow my HP35? And he was, oh my gosh, you've got an HP35 and you're willing to let me use it? I could not have been more shocked if I had, say, been in London and I encountered the Queen and she said, "Oh, going out for dinner? Well, why don't you take the crown jewels? You'd be smashing in them. Just bring them back when you're done with them." I took it back to the desk and I set it down ever so carefully. I was so afraid of dropping it or damaging it in some way, and I turned it on ever so carefully, so scared of damaging it in some way. But that was my first experience with a scientific calculator. The other thing I remember that summer was what we called the electrolytic capacitor caper. Some of us, summer employees, we found a large box of aluminum electrolytic capacitors, and we decided to wire a number of them in parallel to try an experiment. We had heard stories of charging a giant capacitor and letting a transistor radio operate from the stored charge. Urban legends said it would operate for hours on end, but we wanted to try that. So we wired together enough capacitors so that we had a rated capacitor of 1.04 farads. That would make it one of the largest collections of capacitance in the free world at that time. We charged it to 10 volts. Then we removed the power supply, connected to transistor radio, turned it on, and it was still playing 45 minutes or an hour later, although the audio was getting a little distorted because the voltage had dropped to maybe about 6 volts. Well, let's go back to the rogues gallery. This fellow here, Bob, he was in on the electrolytic capacitor caper, only he had a more sinister, what would you say? He used it in a more sinister way. He'd like to invite unsuspecting people back into our little back office where we had the capacitors, and he would charge them up to 10 volts, and then he'd take a screwdriver and slam it across the capacitor terminals. Well, you've got, let's see, 1.04 farads at 10 volts. That's 10.4 coulombs or 10.4 ampere seconds of charge stored. You're going to discharge that in some tens of milliseconds or so. That's a very large current. And that current causes a loud pop and makes sparks fly from underneath the screwdriver. And Bob liked to do that to unsuspecting folks to test their startle reflexes. Bob was also the first person I ever knew who did something like email. He found a 300 baud modem in a terminal, connected them together, and on some days after 5 o'clock, after the workday was over, he would take the cover off the laboratory telephone, connect the modem to the telephone line with alligator clips, and he would dial up a port at the University of Illinois, and he could log on to his account and he could check and see if he had messages from a colleague of his who was still over there. They sent messages back and forth in primitive form of email in 1973. Then we have this fellow. I later worked with John at a full-time position in another company. John was interesting. He had an avocation as a piano player in a 1950s rock and roll revival type of band. And this fellow, Pat, I had an adventure with him in the fall of 1973 at the University of Illinois. We were both in the same advanced math class, a class called Complex Variables. It was a miserable experience. It was the only class I took as an undergraduate where I was legitimately in danger of failing. I didn't fail. I managed to pull through it, barely. And at least I had the foresight to put it on pass fail so it didn't make a ding in my overall grade point average. So at the end of 1973, I went back to the University of Illinois for what was to be my last semester as an undergraduate. In January of 1974, I'm working as a practicing engineer in another company, but that is another story for another time. So Sangamo's summer student program didn't last much longer after I was in it. I honestly don't know when they finally had their last class of summer employees, but Sangamo was beginning to wind down their operations in Springfield in the mid 1970s, and by 1978 they had departed from Springfield, and the Sangamo era in central Illinois came to an end. Anyway, we appreciate you visiting the past with us. Hope it's been worthwhile, and we'll see you in the next video.